Hello, everyone, and welcome to our Sunshine Coast World Oceans Day Festival and our fourth talk in the 2023 Nemo Talks series. I'm Suzanne Sanger, the Executive Director of the Sunshine Coast Conservation Association. We are partnering with Rhizome Up Media and the Green Film series with support from the District of Sechelt, Sunshine Coast Regional District, and Sunshine Coast Credit Union to bring you this year's festival. The SCCA works to protect lands and waters on the Sunshine Coast in the territories of the Squamish, Sheshalf, Pliamin, Klahoose, and Hamalko First Nations. I'm zooming in today from Chuckwelt, or Gibsons, at Catsum Howe Sound. The SCCA is so very grateful to the First Nations of this region for stewarding these lands and waters since time immemorial. We take great inspiration from the respect, reverence, and connection that Indigenous peoples have always had with nature. And it is in this spirit of connection that we bring you our World Oceans Day Festival. Every year on June 8th, people all around the world come together to celebrate World Oceans Day. And the United Nations designated this day to inform the global public of the impact of human actions on our oceans and to develop and mobilize a worldwide movement of citizens for the ocean. The theme of this year's program is Planet Ocean, Tides Are Changing. As our planet warms and our waters warm and our seas rise, we must join together to tackle the challenges ahead. The festival program includes in-person and online screenings of thought-provoking and inspiring feature and short films, interactive citizen science activities, and of course, these Nemo Talks, all of which are geared toward inspiring, enlisting, and connecting people to work together and take action to protect our oceans. Today, for our fourth talk in the series, we're excited to host Heather Earle from the Hakai Institute to hear about their Sentinels of Change project. I'm going to pass it over to Diane to introduce Heather for us, please.
Great, thanks very much. So I'm here to introduce Heather, driven by communities and led by the Hakai Institute. Sentinels of Change, the program, is a decade-long project that uses light traps to investigate the ecology and dynamics of a critically important species in our inland sea, Dungeness crabs. The first year of the Sentinels project had one trap on the Sunshine Coast within a network that spanned the Salish Sea. This year, there are 3 more. Throughout the spring and summer, groups of dedicated volunteers check the traps regularly and watch the crabs and other species come and go. Join us to hear about our findings so far and how important community science is in our efforts to understand ecosystems and environmental change. Heather Earle is a marine ecologist with the Hakai Institute and project lead for Sentinels of Change. She works with communities and scientists across the Salish Sea to monitor nearshore ecosystems and and track change. Welcome, Heather, for coming to join us today and tell us about your project.
Awesome. Thank you so much, Diane. I'm just going to share my screen. And if you can just let me know whether you can see. Yes. Okay. I'm getting a thumbs up. Perfect. Great. Okay. So thank you for that wonderful introduction and thank you for inviting me today. It's really nice to be here with everyone. I am coming to you from Kitasoo Hei territory. I am in the town of Klemtu up on the Central Coast, and I'm very excited to tell you all about this project. So to give you a little bit of backstory, so I'm a marine ecologist with the Hakai Institute, and Hakai does all kinds of research up and down the BC coast, and that's from ice fields to oceans. And so right now what we're looking at is our Calvert Island Ecological Observatory. We also have space like this on Quadra Island, and we have offices in Victoria and Vancouver. So we've got all kinds of labs, we do all kinds of research. And we work with a huge diversity of partners, academic partners, community partners, First Nations. So the project I'm about to tell you about, it falls more into the marine realm from ice fields to oceans, and it is called Sentinels of Change. So it leverages community science to monitor change across the BC coast. And this one is special because it also involves a cross-border collaboration. So Washington and BC working together. And really, this project is focused on biodiversity and population dynamics of marine invertebrates. And a big way that we get at that is with light traps. So you can see a nice bright light trap at the bottom of this photo, tucked under the ramp there. This is a dock in Miners Bay on Main Island, looking out towards Active Pass. So they float at the surface and turn on at night. And when we zoom in a little bit and pull them out of the water, this is what they look like. So you'll recognize the proper science bucket on top there, and a 5-gallon jug with some funnels, 6 funnels, and that's how the little critters get in. And then when you haul this thing out of the water, everything drains through the bottom, if you can see my cursor, through this cod end. And that's where the whole sample gets kind of concentrated, and you can unscrew that and retrieve it. And so this is what they look like from above at night. So floating at the surface, nice and bright. And then this is our network on the far right here. So we've got traps all over the place. You can see the black dots represent the Puget Sound, Washington sites, and the orange dots are the ones in our network. And each of these sites has a light trap. And so a lot of folks, when they see these traps and they find out that we're studying Dungeness, their first question is, how do you even catch Dungeness in a trap that floats at the surface when all of the Dungeness crabs are crawling around the bottom? And as many of you might know, what it comes back to is the very interesting and dynamic larval life histories of marine invertebrates. So they have these amazing life cycles where they actually start out looking quite different from the species that we recognize. So when we go walking on the beach or snorkeling or diving, we probably see a lot of our favorite kind of sea stars and sea cucumbers and those kind of critters. But often folks are surprised to learn that they start out looking really different. And they go on these massive ocean journeys, sometimes going kilometers, many kilometers offshore or many kilometers up the coast, traveling on ocean currents. So these larvae along the top, I promise you, you'll recognize their adult forms, or at least some of them when I show you. But just for fun, does anyone have any guesses as to what we're looking at here? You can throw it in the chat, or you can unmute yourself. I sometimes think that one in the middle looks like a stellar sea lion, but that's not what it is, although it does look like that. Any guesses before I reveal?
So we're looking at larval stages, right?
Yes, we are looking at larval stages and then wondering what they might grow into as adults.
Oh. So is the second to the left perhaps a crab?
It's close. It's the right phylum. Okay, let me show you. So if I can, yeah, oh, there they are. Yeah, so we have an urchin, a red urchin for the first one, barnacle. So barnacles swim around before they glom onto the rock and spend the rest of their lives in the same place. That sea lion is actually a sea cucumber. We've got a nudibranch and a sea star. And there's many, many, many marine invertebrates that have life cycles like these. So when you're swimming in the water, you think it's just water that you're accidentally swallowing. It's actually often a lot of other things as well. So it's kind of cool to think about when you're looking off the dock or out on the ocean. So to bring it back to crabs, they also have really amazing life cycles. So they start out as these fragile little zoea on the left, and they molt and grow and molt and grow. And if they can survive all the predators and all the challenges that are stacked against them, they can turn into this beautiful crab on the right. So this gives you a bit more of a sense of that life cycle. It's still quite simplified, but you'll see these eggs, these orange eggs that the female has tucked under her abdomen to protect them. Once those hatch, they turn into the zoea that I just showed you. And there's 5 of these stages. And then the last larval stage is the megalopa stage. So that is right before they settle as juveniles. And they're strong swimmers. They're starting to look like crabs at this stage. And they've got these big eyes. So they're very attracted to light. And these are the ones that we target in our light traps. And these are the ones that we're quite successful at catching. And that's quite a useful stage to have data on, because when you catch a bunch of those, you know that there's a lot of crabs in the area that are about to settle. So it gives you an idea of the kind of influx of new crabs in a given area. And so this is what they look like in real life. They're quite adorable. They're about the size of your pinky nail, and they're in this stage for a couple of weeks to a couple of months, depending on the latitude. So colder areas, they take longer to grow. They're very strong swimmers, and they perform a diel migration like many other creatures in the ocean. So that means that they're hanging out on the bottom during the day, and then they're swimming up to the top at night to feed. And the reason they do that is because there's fewer predators, or at least the predators cannot see them at night as easily. So our light traps are kind of coming on in the exact right place at the exact right time, and that's how we get them. So to give you a little bit of context about Dungeness and why we're doing this. So Dungeness crab, they range from the Pribilof Islands in Alaska all the way down to Baja, Mexico. And they're one of the highest valued and heaviest exploited species along the West Coast. So they support recreational fisheries, food, social, and ceremonial indigenous fisheries. And there's a really massive commercial fishery for Dungeness crab that puts them on shelves locally as well as globally. These guys tend to not be too deep, so usually no deeper than 50 meters. They like soft, sandy bottom substrates. So you'll find them in eelgrass meadows or just on the sand. Sometimes the juveniles are in oyster reefs. And they're opportunistic feeders, so they eat whatever they can come across that they are bigger than. So bivalves, fish, shrimp, other crabs, dead things. They're great at cleaning up carcasses and things like that. And there's a lot of things that eat them as well. So a lot of birds, sea otters, octopuses, river otters, other crabs. So the invasive European green crab are a big problem. They like to eat the juveniles. And sometimes it's actually Dungeness eating Dungeness. So for a newly settling cohort, the biggest problem for them can be the cohort that settled, a month earlier and is just big enough to start picking them off. So there's some of that as well. And all of this is just to say that these guys are a very important piece of coastal ecosystems. And there are a lot of threats that are kind of growing for Dungeness crabs. So climate change is a big one. So increasing temperatures, so warmer marine waters stress crabs out, and they actually increase their metabolic rate. And that means that they have to eat more to survive. And so if you've heard of the recent snow crab fishery collapse in the Bering Sea, that is actually one of the leading hypotheses as to why that happened is increased temperatures causing their metabolic rates to increase. And then basically they just ran out of food and started eating each other, and the fishery completely collapsed. Ocean acidification is another one that's a big threat to crabs. Crabs have shells, they're calcifying organisms and they have to maintain those shells. And more acidic oceans makes that really hard. So that means that it's taking up more of their energy to maintain the shell, and they have reduced growth rates and survival rates. Hypoxia, so that just means water that has less oxygen in it. So warmer waters can't hold as much oxygen. And so you get these larger dead zones. And that's what we think happened in this picture. So this is taken at Kalaloch Beach on the Olympic Peninsula last June. And they think that the hypothesis is that this was a dead zone. There was a big pocket of oxygen poor water, and it caused a lot of crabs to die. They couldn't escape that dead zone. And then harmful algal blooms are increasing, and those are very toxic to crabs as well. For fishing pressure, globally, there's increasing fishing pressure on crustacean fisheries, and that's because fish stocks are declining. So people are starting to see more of a switch to crustacean fisheries. And we have also seen local depletions around our coast. Lots of harvesters are reporting that it's hard to find enough crabs to harvest and eat. And some places have actually implemented closures, spatial closures, and seen the stocks rebound. So there's a lot of pressure on them in some areas. Okay, so I just want to sort of take us back to how this project began. So that means going a little bit south down into Puget Sound. So Swinomish territory is right around here. These 3 dots represent Swinomish light traps. And so harvesters there were seeing a lot of unpredictability in the fishery. They wanted to understand that a little more. So they started using light traps in 2018 to get at those other parts of the life cycle. And then over the past 5 years, that's grown, and they've got a whole network down there. called the Pacific Northwest Crab Research Group. It's this awesome group of tribal managers, state managers, and scientists that work together to fill knowledge gaps and inform better fishery management decisions. So they were really inspired by work done in Oregon, where Dr. Alan Shanks, with a single light trap on the Oregon coast, showed this really strong relationship between the larval abundance in 1 year and then the commercial catch 4 years later. And that's kind of the time period that it takes for those little larvae to grow into a legally harvestable crab in terms of size. So the Swinomish tribe and the whole network down there are really interested in seeing if they can also predict commercial catch or harvestable abundance years in advance. So we saw this at Hakai and were pretty inspired, and we wanted to expand this network north of that border, north of the international border. So in 2021 and 2022, we worked really hard. We built a bunch of light traps, and we traveled around the Salish Sea and trained people up, showed them how to use them, recruited all kinds of partners, and ended up with this wonderful network. So the sites in orange are the ones we had last year, and the sites in red are the new ones this year, minus a few that are a bit north of the extent of this map. And then those black sites are the Washington ones. So all of these represent light traps, and all in all, it's pretty amazing coverage across this area. And everyone is doing the exact same thing and has the same traps. And our partners are pretty amazing too. It's a huge range. So we work with a lot of First Nations, a lot of environmental NGOs, just community members, community scientists, school groups, aquariums, businesses, all kinds of folks. And that's a real strength. We get lots of different kind of expertise and perspectives, and we see that as a big win for our project. So in 2022, we had 20 sites, we had over 200 volunteers, and we had over 13,000 fishing hours. So that means lights on in the water. And just as a bit of a recap, we always have our traps in from April 15th to the 1st, same thing this year. But we caught our first crabs in the Southern Gulf Islands. So Winter Cove and Retreat Cove on Saturna and Galliano. And then we caught just under 20,000. The most were actually seen in Horseshoe Bay, the most in a day at 1,500. And then Hope Bay on Pender Island caught the most through the whole season. And we actually have online this little kind of map that shows you the date on the bottom left here. And then you can see the white lights mean the lights are on, or the white dots. And then those crab icons show you where the crabs are caught. So they start out in the Southern Gulf Islands, which makes sense because we think they come in through the Juan de Fuca Strait, and then they kind of go up and around. So finishing in the mainland in those kind of Vancouver sites. And everyone's catching crabs in July, and they kind of start to peter out getting into August. Still some here and there, but less. And then we pull our traps out of the water in September. So you can, I'll show you the link to our website a little further down, and you can see what's going on this year in terms of where the crabs are showing up right now. There we go. And then just to give you a sense of kind of how they're coming in. So they kind of tend to come and go in these big pulses. So this shows us the number of crabs caught per hour across all of the sites. And so you can see most of them are coming in through mid-June to about late July. And then there's a bunch in August, but not the same kind of peaks. And then just for fun, I added the Pender Harbor site. That was the only one in the network on the Sunshine Coast last year. This year we added Seashell Inlet, Gibsons, and Powell River. But Pender Harbor, so they didn't catch as many. You can see they're not really driving those peaks. But I always love to remind people that it's really important data, even if you are getting zeros. It's just as important for us to know where the crabs are not showing up as to know when they are showing up. So we really value this data. And then just another way of looking at it, here's a map, and this one includes the Washington sites. So the size of the bubble shows the average crabs per hour of fishing for the whole season for each site. So here's Pender Harbor in here with the little bubble. You can see those Washington sites. They've got the most, they're really catching them, but a lot of the crabs are showing up in the kind of southern Salish Sea, or southern down here, and then central kind of around here, less in the north. We also have temperature data. So we have little temperature loggers near our traps. And I've ordered these latitudinally. So the most northern sites are along the top, and then we kind of move south as we go down this slide. You can see the temperatures actually get cooler to the south. So that's, we suspect, because of the Fraser River and the colder water coming out there. But it's kind of interesting to see how every site gets actually quite warm. And some of them spend a lot of time in really warm temperatures, like above 20 degrees. And these are half a meter down, so surface water. And then finally, last graph, we looked at our crabs per hour for each site and sort of put temperature over top of that. So kind of trying to understand what conditions the peak crab arrival is exposed to. So for example, Horseshoe Bay, they got most of their crabs in August, or in July, late August, July, and that was actually a really warm period. So those crabs were exposed to some pretty warm, stressful temperatures. Whereas somewhere like Ford Cove on Hornby Island, they got their peaks earlier in the season during cooler temperatures. We also get other species. These are pretty fun. We actually have an iNaturalist page where folks like to upload pictures, and experts from all over the place identify them. But we get things like flatfish, other, I think this is an anchovy, pipefish, octopus, hermit crab, squid. We've got more. But this is a really fun part of the project. We don't ask everyone to identify everything because it's the Dungeness crab is kind of the minimum, and then everything else is optional. But it is pretty fun, and some groups like to design little projects around a specific species in addition to Dungeness crab. So I'm just going to end sort of by telling you where we're going with this, and then we can open it up in case there's any questions. So one of the big goals for us is looking at forecasting harvestable abundance. So really, we're trying to answer the question, can the light trap data be used to forecast adult crab abundance years in advance? And this would be really helpful to managers so that they can anticipate how many crabs there are going to be, and they can adjust their quotas. It can also be helpful for harvesters, and it can prepare them for potentially low harvest years and allow them to switch to other fisheries in those years if they can. This is something, Alan Shanks did it with one light trap on the Oregon coast. We've got way more than that now in the Salish Sea, and that's because it's pretty complicated. It's a very different system in the Salish Sea, very different currents and patterns. So it's not quite like the California current system that you get down in Oregon. We're also doing some lab experiments this year. So we want to understand how climate change impacts affect these larvae and whether those effects persist even after the crabs molt and move on to the next life stage. So we're going to be taking some larvae and doing some lab experiments on Quadra Island to investigate that. And that's something we're starting this year, and we're hoping to continue in further years. And then finally, down the line, we'll be doing some genetic studies. So that's really trying to get at, where are these crabs coming from? Where do they go? Are there sort of distinct populations in certain areas like fjords or inlets? Or are they all just mixed together, and kind of, is there a lot of genetic flow between the different areas? And that's really important for understanding kind of management areas and management units. So I'll just end on this note. So this project is so far really successful, and that's really because of the communities that we get to work with. There's a lot of reasons to do community science. One of the big ones is just getting the community engaged. There's tons of education opportunities with this project, and it helps grow people's science and ocean literacy. So a lot of people have said this is a big highlight for them of their summer, and they've learned a lot, and that's great. We love that. It also it informs people, and it helps them be better advocates in their communities for the ocean and for the marine environment. And then from our perspective, it is amazing because it gives us this really broad, long-term, large-scale trans-boundary data set, which is a really powerful thing. And it's something we absolutely couldn't do without our communities. So if you want some more information, there's our website. I can come back to this slide, and my email. So feel free to reach out. And I just want to end by saying thanks for listening, and thank you so much to all our partners, but also to the Sunshine Coast partners, the Shuswap Nation, the pods, the aquarium, and Volunteer Pearl River. I'm super grateful for everyone's participation. So thank you.
Thank you, Heather. That's amazing. It's really great to land on that slide and to see how many different groups on the Sunshine Coast are already supporting your project and working with you. That's
Yes.
one of the excuse me, big takeaways from your talk, sort of building off of the other talks that we've had over the course of the week, is just how connected everything is. And it's like the climate change and the temperatures affecting the crabs and ocean acidification, and I just have so many questions. So we're going to move into the Q&A part of the program now. I'll be taking questions. It's a pretty small group, so you can maybe if you stop sharing your screen,
Sure.
then I'll be able to see folks. So people can use the chat function in Zoom, or, flick on your video if you don't mind, wave your hand around or pop a question in the chat, and I'll be happy to take questions from folks.
Thanks. That sounds great, Suzanne.
Yep. And if nobody wants to jump in quickly, I have a million. So you did, on your last slide, you did show that you've got folks doing traps on the coast. So I think you said Shishal Nation, Pods, folks in Pal River, and the Nicholas Sontag Marine Education Center. So how do, if the SCCA wanted to do a project and do some traps, like how do people get involved?
Yeah. So usually when folks reach out to me, I sort of find out where they are and if there's already a trap in their area. So reaching out to me, I think Ian kindly put my email address in the chat. So please do feel free to email me. I love kind of connecting volunteers with existing trap coordinators and traps. And then of course, we also love new traps. So if you're in an area where you don't see a dot in your area on that map, and you've got some volunteers and some time and you'd love to kind of take on a trap, then please reach out as well, because that's a lot of fun, and we love kind of filling gaps on our project map. Yeah.
Very cool. There's Diane.
You have a trap in Seashell Inlet, Heather?
We do, yes. The nation is running that one. Yes, yeah. So
Right.
for anyone in Seashell that might want to help, I can put you in touch.
Right. Perfect. Good.
Yeah. And I just see Maggie's question about hypoxia. Yeah, hypoxia is when there's depleted oxygen in the water. Thank you for that, Diane. But it can be caused in a lot of ways, and one of the big ones is that warmer water just can't hold as much oxygen. So as climate change warms our waters, they just become oxygen depleted.
I was really curious about, so in your presentation, you described that it's a 4-year cycle from when the eggs are hatched to when the crabs, we can harvest them. And but I wasn't sure, like, how long from when they're eggs until they get to that phase where they're actually little crabs.
Yeah, that's about 4 months, but that can kind of vary a bit with latitude. So it takes longer for them to grow to that benthic stage where they're crawling instead of swimming in places like Alaska, the northern part of their range. But yeah, about 4 months in the water swimming around, and then from there on out, it's just crawling.
Very cool. Let's see, just want to check the chat. Okay, so the Pacific Northwest, was it called the Pacific Northwest Tribal Network?
Crab Research Group.
Crab Research Group, sorry. But it's a collaboration with First Nations. It's a transboundary collaboration with First Nations on both sides of the water.
Yeah, so they started it down there. I just put their website in the chat. I'm pretty sure that's the right one. But they started the light traps in 2018, and that was really led by the tribes down there. They're the ones, there's a lot of tribal involvement down there. And then we have First Nations on this side doing the same thing within our network as well. So it didn't start out as a transboundary partnership, but we work really closely with them and talk to them a lot, and are co-writing some manuscripts and things like that. So it's really wonderful to have that partner across the border, especially when you share an inland sea and the crabs don't really, they don't respect the border. So it's really important to be able to work together on that.
Yeah, very cool. I was in Seattle recently for a conference called the Hope for the Salish Sea conference, and it was a lot of different NGOs, and also some of the folks from like Tulalip and some of the other tribes down there. And yeah, they're really engaged. They work with government, and there's like all these partnerships that I feel like, you know, on our side of the border, maybe we could take some inspiration from. Maybe.
For sure, yeah, and I'd say the same up here. There's a lot of First Nations that are really engaged, and I see it in this project as well. They're really excited to work with us to explore the different parts of the life cycle, and just have that really like deep, long-lasting connection to the ecosystem as well. So it's wonderful to be able to work with groups like that as well. Yeah.
Okay, if no one's gonna put their hand up, I've got a whole list of, I was sort of taking notes as you were talking, Heather. And okay, so one of the things that I was thinking about was, you talked about how the warm water increases the metabolic rate of the crabs. And so then they get hungry and they eat more. And that was, you know, and then if there's not enough food because of all the other things, then they'll end up cannibalizing each other.
Yes.
And so, I mean, how does this show up in like where they, I guess maybe that's the Fraser piece, right? Where the Fraser comes out into the sea, the cold water is more livable for them. So I wasn't really sure how that translated into where their populations are big in your map.
Right. So really like that showed up. I don't know to what extent that has impacted Dungeness crab. It's possible that that has happened, but really that's something that's been talked about a lot recently in reference to the snow crab fishery. I'm not sure if you saw that in the news, where there was like 1 billion crabs expected and 0 crabs showed up for that fishery, and they had to close the season. They suspect it's because of those warm waters and the increased metabolic rate. So I think it's hard to say sort of like just with our surface temperature data that we collect what the adult crabs are exposed to, or like across that whole range, especially because it's quite patchy. We don't have data for everywhere, but that certainly is something that could impact Dungeness populations as with warming marine waters. Yeah, does that answer your question?
I think so. Yeah, because I'm still like, the questions are still formulating in my mind as I think about your presentation. So it's, I mean, sort of what you said, like, you know, the data, the more the data comes in, the more you have answers to some things, and then like the more questions you have too. Maggie was asking, what do the larvae eat?
Yeah, good question. So they eat other zooplankton. So that means other little larval things like shrimp, copepods. Sometimes they'll eat phytoplankton. So that's like the algae, and the like diatoms in the water. They will eat dead things that they come across. They will eat whatever they can. They're pretty small at that stage. So there's less things that are smaller than them. Sorry, there's a float plane taking off outside my window, if you can hear that. So they eat a lot of different things. And then one thing I just wanted to add is that I've recently been getting some emails from folks who fish for salmon, and they're cutting open the salmon, and inside the guts of the salmon, they're finding hundreds of Dungeness crab larvae. So those are also a really important food source for fish and other species that we rely on in the Salish Sea.
Has it always been thus? Is this one of the things that we've been talking about lately, as, you know, as different types of prey diminish, then, you know, different animal, fish and marine species are eating different things. And so is this new data to say that they're newly eating the crabs? Did they have something else they were eating before? Or has it always been like that?
I suspect they've probably been eating them all along. I'm sure that varies from year to year in terms of kind of like which zooplankton populations. So zooplankton encompasses the crab larvae. Zooplankton is just kind of like the animals that are in the plankton. So I think maybe if there's a big Dungeness or crab larval year, they might eat a lot of crab that year. And then if there's much less for whatever reason, they might switch to something else. Yeah.
Okay,
good question.
I'm gonna look back at my list.
No problem.
Yeah, so ocean acidity impacts on shells. Yeah, did you want to sort of
Yeah,
talk a bit more about that? Yeah.
absolutely. Yeah. So as the ocean absorbs more carbon dioxide from emissions, it gets more acidic, and shells are more easily dissolved in those acidic conditions. And so the crabs have to work harder to maintain their shells. And at any stage from larval to adult, that is going to cost energy. And so they're spending energy doing that at the cost of other things. And that we see that with effects on their carapace. So you see that it's starting to dissolve. There's a lot of abrasion on it. It can impact these little mechanoreceptors on their shells as well. And that is really important for swimming for the larvae. And so ocean acidification can kind of deteriorate those mechanoreceptors, and it means they can't swim as well, they can't avoid predators, they can't feed as well. So it has impacts in that way. And then we also see that when it's more acidic, they cannot grow as much. And so we're getting smaller crabs, smaller larvae that are more vulnerable to predators.
Right. I just gotta, oh, Rick's got his hand up.
Hi, great presentation. Very interesting. I didn't know so much about crabs. So I was wondering about protecting them and wondering if glass sponge reefs would be kind of an oasis for them for protection in the ocean. But I'm thinking maybe glass sponge reefs are too deep and the crabs are 50 meters and the glass sponge reefs are like 200 meters. Would that be right?
Yeah, I think you're about right there. You do get some crabs a bit deeper, but mostly they like to hang out a bit shallower than 50 meters or shallower. So there might not be so much overlap between those two things. Yeah, they really like soft sandy bottoms as well. So we find them in eelgrass meadows and just kind of like on mud flats, that kind of thing. That's where we see a lot of Dungeness crabs. But in terms of protection, there's several nations right where I am right now, actually, who implemented their own spatial closures in their crabbing areas because they were seeing they weren't able to harvest enough in those areas. And so they worked with DFO to implement those closures, and the crabs rebounded really quickly. So it's something that shows that like if you close an area, they will come back. So that's very promising.
Excellent. Thank you.
No problem.
It's always amazing how nature, when you stop trashing it, rebounds. It's amazing that way.
It's quite resilient in that way.
Yeah. Yeah. So Leanne sent a question, I think maybe just to me. What criteria do you use to place the light traps?
Yeah, good question. I mean, a big one is going to be just what's accessible to people, because we are relying on community scientists to do this, and it has to be feasible for them. So, you know, some of the interesting areas might be offshore a little bit, or like, you know, a little further out, like in Boundary Bay or something like that. But those are pretty hard for people to get to. They have to boat there. So really we target floating docks because then they can go up and down with the tide. And we like areas where the water's not totally stagnant, but it's not too exposed, because our light traps can take a beating sometimes with the waves. So that's kind of what we end up with, is docks that are kind of in communities and sort of semi-protected. And certainly there's bias with that kind of site selection, but we still think that we're getting a picture of the overall kind of larval delivery to an area. Even though there might be some areas that get a little bit more nearby, it still gives us a sense of what's going on.
Very cool. Yeah, it makes me think that there's an opportunity maybe through local governments, permitting processes, the marinas, to sort of like inform people about this and say, hey, you know, here are some places where the Hakai would like to have,
Yeah.
you know, like to have light traps and do testing. And
Yes.
yeah, just working like it. Oftentimes we, you know, we work through the NGOs and First Nations more and more, thank goodness, but, you know, not like local government is one of these I'm really finding
think
more and more that if we can connect up with them and they can include it as maybe part of their development permit area process when somebody's building a dock or, I don't know, there's got to be creative ways to get the word out.
For sure. And there's so many people around that are keen to take part. So I think there's lots of opportunities there. Go
Yeah.
ahead, Diane.
So my question comes then from a different angle. So you have to have safety factor to get people there safely. And you have to have the light traps where they're not going to be vandalized, I would think, because I immediately thought about False Creek and areas like that, people just pulling them up to have a look at them,
Yeah.
and things like that, which does happen. And that then took me to the other thought is eelgrass beds are so key for crabs, and eelgrass restoration is sort of another facet of that Dungeness crab restoration, not restoration, but trying to enhance their habitat as well.
Yes, definitely. They love that habitat. And there's definitely some areas where we do kind of want to target, like I said, mentioned Boundary Bay, kind of out by Delta and Tsawwassen, like that's a huge crabbing area. And we actually haven't been able to set up a light trap there yet. We just haven't found partners that have capacity. So we do kind of want to be strategic in some sense with where we put them, because we want to have the data on those areas, kind of like know how many crabs are coming into that very important crabbing area. And you do bring up a good point. We've actually been pretty lucky with vandalism. Most of our places, some of them are kind of like locked behind a locked marina gate or something like that, and many of them aren't. And we have little signs that we put up, and people do tend to kind of look out for the traps because they learn about them and see the critters that we catch, and they kind of get protective of them, which is wonderful.
Yeah.
So we've done well with that, but yeah, it's something on our minds as well.
Right. Yeah. I just wondered, I was, talking to the First Nation about the Seashell Nation folks, and they were quite concerned that they wanted to keep them sort of away from the main view of most people.
For sure.
I gathered there was a bit of concern that way.
Yes. Yeah.
Yeah.
That's understandable.
Yeah, the pros and cons of curiosity.
Yeah, especially with a bright light in the water.
Leanne was asking if there are some sandy beaches that might be helpful on Gambier or Keats. And I want to add to that, like the Islands Trust Conservancy. So we're SCCA partners with them on, like we've got a covenant on Sandy Beach on Keats Island. And so I wondered if you're working with them and if you had any, wish list spots.
Oh yeah, I've got a list for sure. Gambier would be wonderful, or Keats. We have one in Horseshoe Bay and then one in Gibsons. So there's sort of a bit of a gap in terms of what's between in Howe Sound. Yeah, so both those areas would be really cool. We work with the Howe Sound Marine Stewardship Initiative and sort of coordinate all the Howe Sound traps with them, which is great. Because then they have a sense of what's going on as well. But really, like, one of the big considerations, because it is April 15th to September 1st, and we try to check our traps every 2 days. So that can be pretty quick if there's no crabs. Sometimes it's a bit longer if there are crabs. So like anywhere from 20 minutes to an hour, maybe an hour and a half if there's like a lot of crabs. So it's making sure that there's enough people that can, sort of commit to that. Which is really good to be kind of upfront about at first. But often, like, we have a lot of sites and most of them are quite successful with checking on that schedule. So yeah, just kind of making sure there's the right sort of volunteer base around is also a big consideration for us.
Totally. Yeah. Well, and that's why these conversations are so good. It's because okay, I'll pass it over. Diane, did you want to say?
Just a quick question. So what is this specific season, Heather? I don't know if I caught that.
So the crabs tend to, like, the larvae kind of hatch in the winter, in sort of late winter, or I guess midwinter, sort of December, January. And then they start to return to the like near shore environment as megalope around April. So April 15th is when we start. That's pretty early. We usually don't get them that early.
Mhm.
We got our first ones May 7th this year. So and then that window can last into September even. Like we pull our traps out of the water September 1st. Puget Sound, they do that a little later and still catch some crabs, but we think we capture most of that window between April 15th and September 1st. Yeah.
Okay, so that's the season when you have the light traps active.
Exactly. Yeah.
Every 2 days. All right,
I
this is
know.
good to know. If we're going to try and recruit people, then we need to know exactly what they're up for. And you provide training and gear.
Mhm.
Yeah.
Everything is provided. We come and do an in-person training, come in the night before, set a trap, and then we go through the sample together and go over the protocol. And it's a lot of fun. Every site gets something different, and every day can be different sometimes. Like the amount of variability from day to day in terms of what you pull up can be pretty astonishing. So it's kind of, yeah, it really opens your eyes as to what's in the water and how much it changes.
It's very cool. It's too bad you're not on the coast right now. Tonight we're having an event in Roberts Creek where we're showing uncharted waters and the Marine Stewardship Initiative, you know, the short film about that. We've got Adam from Marine Life Sanctuaries is coming out, and the biosphere people. And so, you know,
That's
we'll be having that
awesome.
conversation. I'm totally going to bring this up with everybody and hit up our partners at the Keats Island Conservation Group. And they're helping us with monitoring the sandy beach on Keats Island, and then Gambier Island Conservancy. Like these are folks I'm definitely going to rally people and send them
Thank you. That's
information.
wonderful.
Yeah. Oh, it's really exciting, and it's fun too. Like you were talking before about how, you know, like being able to participate in something like this, it's, you know, when you facilitate people to get into nature, to get in the water, to look and see, you know, what's there. And like you just said, you know, it's like something different every day sometimes.
Yeah.
This is just one of the most important ways I feel to get people to really like fall in love with nature and want to work together to advocate to protect it. And so
Totally. Yeah, I agree. It really gets people curious. And I think also being like one station in a big network of stations that are all doing the same thing is kind of cool for folks as well. Like, you know, that there's other people across the BC coast that are doing this too, and you can kind of see how their data compares to your data like in real time. So that's also kind of a nice feeling, I think, for some people.
yeah, I think so too. Okay, well, I feel I've run through my list of questions. I'm wondering if anybody else has anything before we let Heather go. I'm just really, it's amazing. And I guess I do want to do one more sort of shout out. The Hakai Institute is such an incredible institution, really, like all the work that you guys do on so many different things. This is one project, but there are so many amazing projects. I really encourage people to check it out. It's seriously cutting edge. It's amazing. And so, yeah, it's exciting to meet you, Heather, and to learn about your project and to hear more from Hakai and yeah. So thank you so much for coming. I'm gonna just let's see, do a bit of fun ending stuff. This is our fourth in a series of 5 Nemo talks. Oh, hold it before I get out of here. Oh, Leanne says the Hakai newsletter is fantastic, and it's so true. We should post a link to that because I love getting that newsletter in my inbox, and I always read it and click all the links. So
yeah, I send it out with my Friends of Forage Fish group.
yes.
When I send the link to everybody when we have our newsletter goes out or whatever to the gang. They love it.
That's awesome.
True. Actually, if you don't mind, Maggie just asked a quick question at the end. Heather, is it all right? Just quickly, she wondered if there are any issues around light pollution in neighborhoods.
Yeah, it's a good consideration because they are really bright. So if you're doing this in a marina where people live on their boats, you're gonna want to be strategic about where you put the trap, so it's not, you know, shining right in their bedroom window. But and then I guess on the flip side, you also want to think about the other lights that are around that might be attracting things to the marina generally, and that is a really hard thing to control. And we don't necessarily need to control it because we have to keep our traps in a convenient spot. So it's interesting. It's important to think about it in terms of when we go to analyze this data, like, oh, this site got a lot of crabs, but that's, right in downtown Vancouver. So maybe that has something to do with it. But yeah, it's a good point, and it definitely attracts attention, which is why we have some signage around so people don't just pull them out and think it's garbage.
Think they're doing a good thing by taking
Yeah,
garbage out.
exactly.
That's too funny. Oh, that's awesome. So
Yeah.
actually, Ian right now is posting, I think, yes, am I seeing that? Or he's about to post a bunch of the links. So we're going to share the contact info for the SCCA and Heather's contact info and our Take Action page on our World Oceans Day website. Through these talks, one of the big things we're trying to do is connect people with projects and encourage people to get involved. So we've got a Take Action page where we're, taking all the different pieces of information and populating that page on the website so people can just go to it and go, okay, how can I get involved? How can I take action to support this work? So I hope folks will go and visit that. And we have one more Nemo talk. Well, tonight I was talking about this before, tonight we've got the Uncharted Waters film screening. We're bringing people together to basically celebrate, the really good work that's happening in Howe Sound. It's such a good news story and there are so many positive things happening there. And so sometimes these conversations can be a little bleak with all the bad news about what's happening in the ocean. So we really want to have fun and have a celebration and eat some food. We got the food truck coming and refreshments, and we'll have a conversation about some of the projects that are going on there. Tomorrow's Nemo talk is we've got Leanne Ennis with us, and she'll be talking, her presentation is called Generation Restoration, Feeding Hope and Resilience Back into Kelp Forests and the Community. And then Diane's got her, you want to talk about your event?
Yeah, today, 3 o'clock down at Trail Bay. I'll be doing a live demo of forage fish sampling. So I'll be down there and talking about forage fish, showing you some pictures, and we'll be doing a sampling and maybe we'll see some eggs. You never know. So we're sampling for forage fish in terms of sand lance and surf smelts. And so we'll be down at the beach, down Trail Bay by Friendship Park. So come down if you'd like to see the process and if you'd like to join our group.
Awesome. Go get wet. It's Oceans Day.
That's right. Dabble your feet in the ocean. It's a nice day for it.
It's a perfect day for it.
Yeah.
And so just for a last thank you to everybody, I want to sort of re-thank our sponsors, District of Sechelt, Sunshine Coast Regional District, Credit Union, and our wonderful Oceans Day working group. Diane and Angela have just been, a driving force behind this work, and Billy Carroll and Rhizome Up Media, helping pull together the program and make sure we have all these amazing folks like Heather to come and talk with us. And this year, I want to give a shout out to the Gibsons Marine Education Center too, because they've really jumped on board with the program and got involved in the festival. So that's great to see, different groups coming together to help raise awareness around Oceans Day. And I think, Billy, Nope. Okay. Without further ado, we're going to let everybody go, and I hope you go and come and attend some of the events, and we'll send you the information about Heather's project. Take care, folks.
Thanks, Heather.
Thank you both. Thanks for putting this on. This is wonderful.
Okay.
Take
Bye.
care.
Aw. Love you too, Maggie. Okay. Evan and Sophia couldn't make it today because they are meeting with Jim Wilson. They're going to train up to do creek assessments, habitat assessments.
What assessment?